Good day, folks. We'll be looking at, as promised, counting principles and probability calculations. Let's start. What is meant by the counting principle? What is a counting principle? Well, when there are m ways to do one thing and n ways to do another, there are m times n ways of doing both. Okay, that's the fundamental principle, counting principle. So, there are 6 flavors of ice cream and 3 different cones. That means there are 18 different single scoop ice creams that you can order. You're buying a new car. There are 2 body styles. There's a sedan and there's a hatchback. There are 5 colors available. There's the 5 colors. And there's 3 models. There's the GL, the standard model, the sports model, and the luxury model. Well, the question is, how many total choices do you have when you go and select the car? Well, let's have a look. First of all, you have a choice between a hatchback and a sedan. There's 5 colors for each one of these to choose from. And for each of the colors that we have, there's 3 different models to choose from. So you can see that bottom sample space is quite big. So you can count the choices, or you can simply do the calculation based on the fundamental principle of counting. So if there's 2 ways to do one thing, 5 ways to do another, and 3 ways to do a third thing, then there's 2 times 5 times 3 ways to do what the whole complete thing. So you've got 30 choices. That sounded a bit ridiculous, but yeah, you've got 30 choices. Independent or dependent are big ideas when we talk about counting principles. It works only when all choices are independent of one another. The counting principle, that is. If one choice affects another choice, in other words, it depends on another choice, then a simple multiplication is not right. But let's see. Example. You are buying a new car, but the salesman says you can't choose black for the hatchback. Well, now things are changing. The black is removed from the hatchback. So you can see immediately the sample space has become smaller. Because your choices are not independent here of each other, but you can still make your life easier with this calculation. Well, for your number of choices will be for the sedan, there's 5 times 3. And for the hatchback, there's only 4 times 3. So there's 27 choices that you are left with when you make your choice of the car to buy. So here's another example. Excuse me. A fast food restaurant has a meal special, $5 for a drink, a sandwich, a side item, and a dessert. The choices are, for the sandwich, there's a grilled chicken, there's an all beef patty, there's a veggie burger, I think veggie burger I misspelled there, and a fish fillet. Okay, for the side dish, there's regular fries, there's cheese fries, there's potato wedges, there's, for the dessert, there's a chocolate chip cookie or an apple pie. And for the drink, there's Fanta, Dr. Pepper, Coke, Diet Coke, and Sprite. How many meal combinations? Please, before we look at the question, you can see this is the menu for the meal, and you pay $5 for it. So how many meal combos are possible? Let's see. Sandwiches. There are 4 stages in this whole thing. Okay, the solution rather. 1 sandwich is chosen from a choice of 4. 2, you choose a side dish, which you have choice of 3. Then you choose a dessert, which is a choice of 2, and then you have a drink to choose, which is a choice of 5. So there's 4 different ways for the sandwich, 3 types of the side dish, 2 different types of desserts, and 5 drink types. So the number of meal combos is 4 times 3 times 2 times 5. So from a limited menu that you can literally write or paint on the wall of this takeout or fast food restaurant, you have 120 choices. It doesn't look like that, but that's real. That's the fundamental principle of counting. So the question here now, you take a survey with 5 yes or no answers. How many different ways could you complete this survey? So there's 5 questions and each of them are yes or no. So simple solution. There's 5 stages being the questions. Question 1, question 2, question 3, question 4, question 5. Each station has a choice of 2, a yes or a no. So the total number of possible ways to answer is 2 times 2 times 2 times 2 times 2. So 2 to the power of 5. Your number of choices to the power of the stages that was available for you. Okay, so there's 32 ways in which you can answer a survey of 5 questions where the answer is a choice of yes or no. Let's look at this example. Ben can take, let's just go back to this example. Why is it 2 to the power of 5? Now folks, if you just look at question 1, there's 2 choices. If we look at question 2, there's a yes, no, 1 choice. There's a yes, yes, 2 choice. There's a no, no, 3 choices. There's a yes or no, yes, the opposite of the first one, which is the 4th choice. But then you can say, okay, that is 2 plus 2. Now let's see. Yes, yes, yes. No, no, no. Yes, no, no. No, yes, no. No, no, yes. Okay, so we have already got quite a few no options between the first 3 questions. So that is 8 options available there. So please just check what you are working with and decide whether in this case it's clearly not 5 times 2, but 2 to the power of 5, because there's 5 stations and each one of the 5 stations has an option of 2. Now you can think about it the way I did. Yes, 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 no, 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 yes, no, 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 yes, no, 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 yes, and then obviously the result of the others will bring you to 8. Let's look at the next one. Ben can take any one of 3 routes from school. Now school is at S. To the center of town, T, well there's 3 routes. There's the blue, the grey and the orange route. And then to his home. From town he might catch a bus, he might, whatever. Take an Uber, might take a walk through the forest just to relax. So he doesn't, he has 5 pathways between the town center and his house. He doesn't retrace his steps. The question is, how many different possible ways can Ben walk home? Well, let's start counting. 1, 2. Okay, so there's 1 way. Let's say blue, brown. Blue, green is another. Blue, funny green, olive green. Blue, pink. Blue, light blue. Then grey, brown, and it repeats itself all the time for each one of those colors. Okay, so what is this? By the basic counting principle, the total number of routes that Ben can take is just 3 ways to get from school to town and 5 ways to get from town to home. So 3 times 5, which is indeed 15 ways. Let's look at another example. Sarah goes to a local pizza parlor and orders a pizza. She can choose either a large or a medium pizza. Has a choice, so there's one of 2 choices, large or medium. Let me get my highlighter out there. Let's highlight them. Okay, so there's already 2 in terms of size. she has a choice of 7 different toppings, okay, and can have 3 different choices of crust. So I suppose thin, medium, and thick in terms of crust. So if we write these down, there's 2 choices for size, there's 7 for toppings, and there's 3 for crusts. So how many different ways can Sarah order a pizza? Well, 3 times 2 is 6, times 7 is 42. When you're presented with a total of 12 different choices, okay, you can make those choices in 42 ways. Okay, Derek must choose a 4-pin digit number. So let's say it's a locker. So he has a 4-digit pin number that he needs to choose. Each digit can be chosen from 0 to 9. How many possible pin numbers can Derek choose? Now folks, this is important now. He needs to make a 4-digit pin number. Each digit can be chosen from the numbers 0 to 9. How many different possible pin numbers can Derek choose? Now the first thing that should go through your mind here is, well, can I have 2 4s? Can I have 3 4s? Are numbers repeated or numbers not repeated? Okay? A very important question. Because if numbers can be repeated, your answer is going to be very different from the answer when you cannot repeat numbers. So by the basic counting principle, because we are allowing for repeat, the total number of pin numbers Derek can choose is 10 for the first pin. So if that is a 1, the 1 is thrown back into the mix. 10 for the second, 10 for the third, 10 for the fourth. Now folks, this is important because here we are allowing repeat. Okay, repeat is allowed. If repeat wasn't allowed, the story would look differently. For the first number you can choose 1 of 10. For the next number you'll only have 9 left. For the number following that you'll have 8 left. And for the last digit you'll have 1 of 7 choices. And you can see that answer is going to be completely different because there you're not allowing for things to be repeated. Okay, let's look at the next question. For her literature course, Rachel has to choose 1 novel to study from a list of 4. So she has 4 books to choose from. She must choose 1 of 4 books. Okay? 1 poem, she must choose 1 poem from a list of 6, and 1 short story from a list of 5. You may have different choices. How many different choices does Rachel have? Well, because she only has to pick 1 of each of these. She can't pick 2 poems, so there's no repeats allowed. Okay, so by the fundamental principle here, she can choose 1 of 4. She has a choice of 4 for the novel. Okay, she has 4 choices. Then her second choice is 1 of 6 poems and 1 short story out of a list of 5. So that clearly shows what? 4 times 30, she has 120 choices. She can make those choices in 120 different ways. Okay, so by the basic principle, 120. Let me just remove what I've written there, eraser, there we go. The next example, James has to choose his options in his final year of study at school. He must choose 1 subject from each of 5 different options. So again, it's 1 from each of 5 different options. The first group, there are 6 subjects. Second group, there's 4. Third group, 5. Fourth group, 2. And the fifth group, there's 4. How many possible choices does James have to make? Well, he's got to make 5 choices, but each choice consists of a different amount of sub-choices that he needs to choose from. So again, by the basic principle of counting, it's 6 times 4 times 5 times 2 times another 4. There's 960 different ways, folks, in which he can make his choices of subjects. Now remember, he must only choose 5. Okay? So there's 5, and he has 960 different combinations that he can choose from. Okay, another example. Jenny has 9 different skirts, 7 different tops, 10 different pairs of shoes, 2 different necklaces, 5 different bracelets. How many ways can she dress up? So again, we see it's the product of the 5 choices that Jenny has. But why am I showing you this? We're repeating the same thing all the time. Look at the number of choices that she has with these options that were given. She's got to choose one from each of those. She can choose them in 6,300 different ways. 63 times 10 is 630, times another 10, 6,300 different ways. Note that the shoes come in pairs, okay? So we must choose one pair of shoes from 10 pairs, not one shoe from 20 different shoes, okay? Simon visits a local fast food restaurant and orders a burger, a side drink, and ice cream. He can choose either a hamburger, a cheeseburger, or egg burger. He can choose, so there's 3 there. Either fries, salad, or a side dish, as a side dish, so there's 2 there. He can choose one drink from Coke, lemonade, orange, raspberry. And he has one ice cream that he can choose from either a cone or a sundae. Now, folks, again, there, by the basic principle of counting, there's 4 choices to be made. Choices are a little bit more limited here, so there's 48 in total. Now here we start thinking a bit interesting. How many even 5-digit whole numbers are there? How many even 5-digit whole numbers are there? Now, folks, 5 digits means there's digit 1, digit 2, digit 3, digit 4, digit 5. Okay, clearly, if we think about this, and they say even numbers. So how many options do we have? Let's start at the last number. We want even numbers. So this can be either 0, okay, 2, 4, I'm trying to write as nice as I can, 6, and 8. Because there's 1, 2, 3, 4, 5 options here. The first number for this to be a 5-digit, there's 5 options for the last digit, yeah. Okay, so we're going to times every one of these together. Okay, for the first one, there's only even 5-digit numbers, so there's only from 0 to 9 is 10 digits, but it can't be 0. So there's 9 digits available for the first number, if you think about this. And then 10 for each one of the others. The others can be whatever they want to. We know even numbers are all divisible by 2 from the tens unit upwards. Okay, so 10,000 digit cannot be 0. So there's 9 choices, as I said. There are 10 possibilities for the thousands, 10 for the hundreds, 10 for the tens, and then only 5 choices for the units. Okay, so by the counting principle, look at that. There's 45,000 choices to be made. 45,000 even 5-digit whole numbers that we can make up. How many words with 5 letters are there that start with a vowel and end with an S? 5 letters again. Okay, so things to notice here, first of all, before we start, they don't have to be real words. So the results like AGXFS or that will also do. There's nothing that's said here that we can't repeat letters. Okay, so we can repeat our letters. And obviously then Y is not a vowel. A, E, I, O, U are the vowels that we're referring to. So A, E, I, O, U, there's 5 of them. Okay, let's have a look. So how many words with 5 letters that start with a vowel and end in an S? The first letter must be a vowel. So there's 5 choices of letters, A, E, I, O, U. The second letter can be any one of 26, so any vowel or consonant. The rest of the alphabet is included in the second, in the third, and in the fourth letter, but must end in an S, so there's only one choice for the last letter. Now look at the number of words that we can make by the counting principle. 87,880, folks. The numbers, this is one sentence with 2 conditions, and the conditions are rather small. But look at the amount of options that we end up with at the end of the day. How many odd numbers are there that are greater than 1,000 but less than 100,000? Well, for a number to be odd, there's only 5 choices in the units digit. Okay? And that's 1, 3, 5, 7, and 9. But it must be less than 100,000. So we're talking 5-digit numbers. Okay? And it's greater than 1,000. So 4 digits minimum, maximum 5 digits. Method 1. The number could have 4 or 5 digits. That's what we're saying here. Okay? In both cases, the first digit cannot be 0. So there are 9 choices for the first digit. The last digit must be odd. So there are 5 choices for the last digit. The remaining digits can be anything between 0 and 9, so there's 10 options for all of them. And there we go. The number of 4-digit numbers we can make is 4,500. The number of 5-digit numbers we can make is 45,000 of those can be made. Therefore, the total number of digits that can be made is the sum of those two, and it's 49,500. Again, remember what the conditions said. How many odd numbers are greater than 1,000 but less than 100,000? How many odd numbers are greater than 1,000, less than 100? Method 2. The total of odd numbers less than or equal to 100,000 is 50,000. The total of odd numbers less to or less than or equal to 1,000 is 500. Okay, so the difference between the two gives you your result. So 49,500. 50,000 minus the 500. Okay, a company puts a code on each different product they sell. The code is made up of 3 numbers and 2 letters. How many different codes are possible? Okay, they put a code on each product that they sell. The code is made up of 3 numbers, 1, 2, 3, and 2 letters. Okay, there's 10 numbers and there's 26 letters to choose from for each of the codes. So there's 5 stages to this number again. Okay, there's number 1, number 2, number 3, letter 1, and letter 2. There are 10 possible numbers from 0 to 9, and as we said, there's 26 possible letters. So the number of codes that are possible here is 10 times 10 times 10 times 26 times 26. 676,000 possible codes. Now folks, please notice again, here the repeats are allowed. The repeats are allowed. If we removed numbers, then this will be 10, 9, 8. Because we've already assigned one number, there's 9 left to assign. If we've assigned the second number, there's 8 left to assign. First letter, 26. Second letter, 25. So it would have been less if we did not allow for repeats. Okay, so reminder, the product. When there's m ways to do one thing, n to do another, there's m times n to do both. A restaurant offers 12 dinner meals. There are 5 choices of starters, 10 choices for a main meal, 4 choices for a dessert. How many combinations of meals can be selected from these options? The combinations, again, the product of the 3. And you can carry on like this. The laptop has 3 choices for processor, 3 for graphics, 4 for memory, 6 for hard drive, and 2 for battery. How many ways can you make up a laptop? 432 ways. It's the product of the 3. Okay, we're looking at an estate agent that uses a lockbox to store keys to a house that is advertised for sale. The access code to the box consists of 4 digits. Very important. Where is my laser pointer? 4 digits. The first digit cannot be 0. Okay, I need my highlighter. The first digit cannot be 0, so already there's 9 left for the first digit. And the last digit has to be an even number, so the last digit is a choice of 5. How many codes are available under these parameters? Now folks, remember, there's the issue again of repeat and non-repeat. Okay? If, that's just a reminder that naught's an even number. If I do allow repeat, there's 9 combinations for the first because it doesn't include naught. Then the naught is thrown back into the pool. 10 for the second, 10 for the third, and 5 for the last. That product for 5. So here digits may be repeated. When digits may not be repeated, you've got to think carefully. Naught is not allowed for the first, so there's 9 choices. Then naught is thrown back in, but another number was thrown in here, so there's still 9 left. The number that went in here is removed, so there's 8 left for the third choice of number, and then your number of even numbers. So if you multiply that out, you can see it's significantly less choices that you have if you don't allow for repeat.